All right, so now we're on part 2 of problem 3 for exam 3. And we need to calculate the angular frequency, standard frequency, and period of motion. So first, we'll have omega, in this case, is equal to angular frequency. Now, you're probably used to omega equaling angular velocity, but in this case, it is equal to angular frequency, and angular frequency and velocity are two separate things. Make sure not to get them mixed together. I don't know why they decided to use the same variable, but they did in this case. So angular frequency in this case only is equal to omega. Then we have frequency, which is equal to the little F symbol there. That's what we'll have as frequency. And the period is equal to T. All right, and so the equations for each of these, we have omega is equal to the spring constant over inertia. All right, and then we have frequency here, which is equal to omega, or the angular frequency, over 2 pi. All right, and period is equal to 1 over the frequency. So you can see as we go about solving these, they kind of line up perfectly. So once we get omega, we can find frequency, and once we find frequency, we can get period. So we'll start with finding omega, or angular frequency, or omega first. So in the problem, it tells us what K is. So the spring constant K is equal to 0.650, and we know what I is from our last part of this problem. It's equal to 1 over 12 mass length squared. All right, and we have the length and we have the mass. So mass is equal to 0.1. And we have the length, which is equal to 0.140 meters. Okay, and so basically we're just going to combine all these together. So we'll get our calculator here, handy dandy calculator. So we'll calculate I first. So 1 over 12, 12 times the mass, which is 0.100, times the length squared, 0.140 squared. Okay, ooh, that's an ugly number. Can we get a fraction here? Oh man, that's not any better. We'll stick with the fraction. It's a little bit easier to type out, a little bit faster. So I is equal to 3, how many zeros is that? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Okay, and then we have K, so we're just gonna plug I and K into omega. So we'll say root the spring constant 0.650 times inertia, or over inertia. So we'll have another fraction there, 49, 3, 1, 2, 3, 4, 5. Okay, and so that is going to give us, here we'll do a little bit of that there, a little bit of that there. So that's going to give us omega here, which is equal to 663.08, and we'll round to the second decimal place. All right, and that's going to be rads a second. Rad a second. Okay, so that's our angular frequency. Now we need to find the standard frequency, which we just need to put this over 2.5, so we can just say divided by 2 pi, and so that is equal to, we'll round again to the second decimal place, frequency is equal to 10.04, and that will be, let's see here, what unit of measurement is that? Let me double check. Hertz, obviously. All right, and now we need to find the period. Okay, and we're basically just going to divide that, put that under 1. So we'll say 1, 10.04. That's going to get us 0.099, and we'll say 6 to keep it fairly similar to the original number. So we'll say t is equal to 0.996 seconds. All right, and those are our values. We have the angular frequency is 63.08 rads a second. Then we have our frequency, which is equal to 10.04 hertz, and our period, 0.996 seconds. And that is it for part 2, and we'll be moving on to part 3 in the next video. Thanks for watching.